All right, this is Mr. McCord's chemistry class, unit 10, lab number 1, titrations. We're going to be using a known amount of a base to figure out the concentration of an acid. So we have a couple things at our disposal. This is called a burette. I've got a funnel up here in the top. This is used to distribute a specific amount of volume of something. It has lines on it just like a gas measuring tube, so we can know how much volume is inside the burette. But rather, we care more about how much volume we dispense out of this. So our marks start at 0 at the top and move down to 50 down this way. So we read this as how much volume of, in this case, base, sodium hydroxide, we're going to dispense into a flask below for a reaction to happen. Now what we're going to be reacting with, again, is an acid. We're using hydrochloric acid, right? And we don't know what the concentration is yet. We're going to figure it out. So we'll have a little bit of our acid down here. We will use the burette to dispense a known amount into our flask until we react them completely. Acids and bases neutralize each other, and we figure out when we hit that neutral point, or close to it at least, close enough for our purposes, with what we call indicators. Indicators, get a little bit closer, change colors at different pHs, but depending on the color that we see in the solution, we can figure out the pH that that's at. We can figure out, therefore, how much acid or base is in the solution. Right? To figure out how much acid is originally in our flask, we continue to add base until we neutralize that, so we're left with water and a salt, in this case, literally salt, on a compound NaCl, floating around in our solution. So our solution is left neither really acidic or basic. Now, the indicator we're going to be using is called phenolphthalein. Phenolphthalein shows up pink in basic solutions. So we're going to hit that neutral point and then pass it a little bit. So that way we're still close to that neutralization point of having the same amount of acid and base, okay? But we're also just a little bit on the base side so we can see the color change, so we know we've passed that point. Okay, so if we know how much base it takes to neutralize a certain amount of acid, all right, and we have a reaction equation that tells us how much acid reacts with how much base, or vice versa, we can say, hey, I've got this many moles of base I used. That has to be equivalent to this many moles of acid I neutralized with. So we can figure out how many moles of acid were in a certain volume of that solution, so moles over liters, right, to figure out the concentration of that unknown acid. So we are using 0.05 molar NaOH for our solution. And we're going to try and figure out the concentration of our HCl. We have about 60 milliliters of NaOH that we're going to put into this burette, enough that we can run the reaction through. If we need to add more, we'll just add more. And we'll be using 40 milliliters of hydrochloric acid to react that with. So when we figure out our molarity of this, it's going to be something per this volume of solution. How many moles of HCl are in this volume of solution? I have a separate video on how to use a burette properly, how to read marks, how to fill it, but I will give kind of a quick overview for the sake of this lab video. Our burette has marks from 0 to 50 milliliters, and again is meant to show how much volume we are dispensing before putting in what we call the titrant, right? What we are using to figure out the concentration of something else. Right? In this case, our titrant is sodium hydroxide. Before putting in our sodium hydroxide, Your burette should be rinsed with distilled water to make sure that you don't have anything acidic or basic or otherwise that can interfere with your reaction. You also want to rinse it with your titrant. So in this case, I would send through some of my sodium hydroxide a couple times to make sure that this is conditioned. This is kind of coated with little droplets of a solution with the same concentration. If there's still a little bit of water left in there or another chemical, that can change the concentration of the titrant that we're using. In this case, this is very dilute. So even a small amount of water or another chemical can change our results pretty drastically. So we want to have a little bit of sodium hydroxide kind of run through the burette. So we have no contamination, we have no more dilution, it's all the same concentration of the same solution. Now also when filling a burette, if you are height challenged like I am, you want to make sure that you do not fill above your head. You should not be reaching up to do anything with your burette. You should take it off of the clamp so you can do it at a height that works for you. It's also great if you can do this over a sink when you're filling, so that way if your valve is open accidentally, you're not spilling it all over the floor, on your table, on your lab partners, things like that. Okay. The valve is horizontal when it's closed. It's vertical when it is open. For some burettes like this, there is only one direction vertically that works, so you might have to kind of take it a whole nother turn around to figure out where that hole is, right, to get it to start dispensing. Your valve should be tight enough that it doesn't wiggle, it doesn't pop out, but it should also be, tight enough, loose enough to, work properly. Your clamp should hold this snugly. It shouldn't be kind of tilted off to the side. It should be nice and straight up and down. You should be able to read the numbers well, because that's how we're going to make a lot of our measurements. This is where a lot of our data is coming from. In this case, what we're going to be titrating is hydrochloric acid of an unknown concentration. We call that the analyte. We want to make sure that the flask with that analyte has room to move, since we're going to be swirling this. You don't want your burette to be so far down that you are clacking against the end of the burette. That can cause it to break. It can cause damage to the flask. It can ruin your experiment. So we want to make sure there's room here so we're not bashing against our burette. Okay. Again, we're using 40 milliliters of our analyte. I'm going to transfer it to this flask. We are using an Erlenmeyer flask, so that way we can reduce splashing or spilling as we swirl this around to get our solution to mix with the titrant, our sodium hydroxide. Our sodium hydroxide is colorless, it's clear. If we put the two together, we should make salt in solution, NaCl in solution, with water. Those are both colorless in solution too. So in order to tell we've got a reaction going, and when the reaction has completed, we need our indicator. Our indicator in this case is phenolphthalein. In an acidic solution, phenolphthalein is also still clear, it's colorless. So we should only see a color change once we have totally neutralized all of the hydrochloric acid in this flask, and then some. We've left a little bit of base left over once all of the hydrochloric acid has been neutralized. So we're going to work up from a low pH of maybe 1 or 2, and it climbs up and up and up until we hit the neutral point of a pH of 7, and then we're going to go a little bit farther into maybe a pH of 8 or so, maybe a little bit higher than that, when we get that color change. We'll take our measurement there. That's called the end point of the titration, and it's close to the equivalence point, where our moles of acid are equal to our moles of base.
Before I start the titration, I want to have a little bit more NaOH in my burette, a little bit more of my titrant than I really need, so that way I can empty some out. That'll make sure to clear the end of the burette to make sure there's nothing contaminating. That'll also make sure that I don't have any air bubbles that could mess up my volume. Now that I have let some NaOH out of the burette, we have our initial volume reading. The meniscus is that sort of curve on the bottom of the liquid there. We read at the bottom to get our measurement. We can also go out to 2 decimal places when we read the value on a burette. So this is going to be 0.50 milliliters. It doesn't matter what your initial volume level is at, as long as it's in one of these numbered ranges from 0 onwards. So we can start at this 0.50 milliliters. It could be 2.67 milliliters. It could be right on 0. Doesn't matter. As long as we know where we're starting and where we end, we can figure out how much titrant, how much sodium hydroxide we are using. And since we know the concentration, we can figure out how many moles of sodium hydroxide we are using. This is an example of a bad titration, or at least not very good. We want our pink color in our flash to be much lighter, not this bright. This is an indication that we have way past our equivalence point. When we reached our endpoint, our solution is very basic in comparison to kind of the neutral point that we are aiming for. But nonetheless, this is a good first trial to know about how much base we should use. I can speed up the process in the next one and dispense about the same amount or less of solution, and then kind of back it off and go drip by drip to get right on the very light pink color that we're looking for. So I look at the volume mark I'm left off at in my burette. I read that off and I figure out how much NaOH I dispensed into the flask to calculate the number of moles of acid that is reacted with, and therefore I can calculate the molarity of the acid originally. This is the color of pink that we're going for compared to this. This means that we've reached the end point of our titration, and it's pretty darn close to the equivalence point, where our moles of acid are equal to our moles of base.